Learn like a pro.
Have you ever really stopped to think about the invisible world that's, powering pretty much everything around us? From the heat coming off your own body to the signal that's hitting your phone right now, it's all part of the single fundamental framework. So today we're going to dive deep into that hidden architecture, the electromagnetic spectrum. So let me ask you this. What do Wi-Fi and X-rays actually have in common? It sounds like a trick question, right? I mean, one connects you to the internet, the other lets a doctor see your bones. But what if I told you they are fundamentally the exact same thing, just operating at a different rhythm? That's the big secret we're going to unlock. To get our heads around the big picture, we have to start small, and I mean really small. We're going to trace the origin story of every single one of these invisible signals, all the way back to the instant it was created. Okay, so here's the key idea. An electromagnetic wave isn't the energy itself. Think of it more like the pathway that energy takes to get from A to B. And it all starts with a single charged particle, something like an electron, that just gets a little jiggle. That one vibration, well, that's the spark that lights the whole fire. And check this out. As that tiny particle vibrates, it creates two fields at once, an electric field and a magnetic field. They pulse perfectly in sync, but at 90-degree angles to each other. It's this beautiful, self-propagating dance that just carries energy away from the source, out into the universe. And here's what makes them true cosmic travelers. You see, a sound wave needs something to move through, like air or water. But an electromagnetic wave? It needs nothing. It can cross the absolute total void of empty space. This is exactly how the light from stars billions of light years away can reach us. They're total masters of the vacuum. All right, so we've seen how a single wave is born. Now let's zoom way out and meet the entire family. We're talking about every possible vibration, every single frequency, all laid out on one magnificent, continuous scale. And this is it. This is that universal scale. Way over on the left, you've got these long, lazy, low-energy radio waves. As we move to the right, you can see the waves get tighter, more compressed, moving through microwaves, the infrared feet you can actually feel, then that tiny, tiny sliver of visible light our eyes can actually see, and all the way up to the really high energy stuff like X-rays and gamma rays. But here's the part that'll really bake your noodle. Whether it's a super long radio wave or a frantic little gamma ray, in a vacuum, every single one of them travels at the exact same speed, 300 million meters per second. That is the absolute, unbreakable speed limit of our universe. It's the speed of light. And there's this simple, really elegant rule that governs the whole thing. Since that top speed is locked in, there has to be a perfect trade-off. So if a wave has a really high frequency, meaning it's vibrating super fast, its wavelength has to be shorter to keep things in balance. It's a perfect seesaw. The higher the frequency, the shorter the wave. And the physical size difference here is just staggering. Seriously, we're talking about radio waves that can be as long as skyscrapers, all the way down to gamma rays that are smaller than the nucleus of a single atom. It's just this immense range, and they're all part of the same family. Now, as we keep climbing up that scale, as we get to higher and higher frequencies, we cross a really critical line. It's a point where these waves go from being pretty harmless messengers to having the power to fundamentally change matter itself. So why is it that you can sit in a room that's just flooded with Wi-Fi signals and be perfectly fine, but you have to wear a heavy lead vest for a simple X-ray? Well, the answer is all about the amount of energy they're carrying and what that energy can do. This right here, this is the danger line. Waves like ultraviolet, X-rays, and gamma rays are vibrating with so much energy that when they smack into an atom, they can physically knock an electron right out of its orbit. That process is called ionization, and it turns a nice, stable atom into an unstable, charged particle called an ion. And that's exactly where the danger to us comes from. When ionization happens inside our living tissue, that physical disruption can actually damage or mutate our DNA. The very blueprint of our cells gets corrupted. And that can disrupt how cells work, and yeah, with enough exposure, it can lead to things like cancer. But here's the cool part. This immense power, both for creation and destruction, is something we've actually learned to control. This final section is all about how we've taken our understanding of this invisible spectrum and turned it into the technologies that basically define our modern world. You can see it right here. As you move across the spectrum, as the frequency and energy ramp up, what we use it for just shifts dramatically. We go from using these waves for, say, global communication on the low end to literally using them for molecular disruption on the high end. It turns out control over frequencies kind of like control over reality. So let's look at the low energy side first. We use these long, gentle waves to carry information. They are the absolute backbone of our connected world, blanketing the entire globe in data that powers everything from broadcast radio in your phone to GPS and your home Wi-Fi. Now let's jump all the way to the high energy side. X-rays are so powerful, they can pass right through our soft tissues, like skin and muscle. But our dense bones, they absorb them. And that creates a shadow that lets us map out what's going on inside. It's just a perfect example of using that high energy for precise, non-invasive diagnosis. And then, at the very, very top of the scale, you've got gamma rays. Their energy is so immense that we use them for, well, aggressive sterilization. They can completely destroy bacteria and viruses on medical equipment or even be carefully targeted in radiotherapy to destroy cancer cells. So let's bring it all home. That Wi-Fi signal, the infrared heat coming from your body, and a medical X-ray. They are not different things. They are all the exact same physical architecture. Those interlocking electric and magnetic fields, all traveling at the speed of light. The only thing that separates them, the one single thing that dictates their power and their purpose, is their frequency.